Welcome to the next video, our second video in the Lighting and Pixels video series where we're showing DMX and E131 digital lighting. So this one we're going to be covering the RGB dumb versus smart pixels, how they're set up. And if I jump back to my slides, we covered so far the intro, the light types, some controllers and examples. Now we're going to go through the RGB setups for dumb and the smart pixel setups, how the equipment's actually laid out and wired. And we're going to show you a hybrid setup, which is what I run at my house. And we are going to cover today in this video number 6 and 7, which is the wiring types for 3 and 4 wire and how the colors get on there. We'll do a different series for the addressing and then a different series for running the software and configuration. So let's get started, shall we? First of all, I want to remind you that the dumb RGBs, and this is about as dumb as they get, they change, all the lights in each one have to change to the same color. So you actually are telling the whole reel to go a specific color, and if there's another daisy chain reel in here, it changes the same color as well. Where the smart pixels actually can be individually addressed because their WS2811 chips in them allow us to address each and every one. So let's go through the components, shall we? And here is a what I refer to as a complex dumb RGB setup, which means it's not one of these. This is about as simple as they get. You have the reel of RGBs, you have the controller, it puts the voltage on the lines, and tells it what color to be. It's actually 4 wire because it's RGB dumb is 4 wire. And it's got a power inverter or converter here. It converts AC to DC, 120 AC off your house into 12 volt DC. And then this one happens to have a little remote control. So when we look at it, this is a more complex version of the same thing. So what you have here is these two pieces of equipment would go in a weatherproof box, and this is your power supply. You would buy it with an output of wattage based on how many lights you're going to connect and maybe how much you want to connect in the future. So for example, if each one of these takes 38 watts, we have 36 watts, 72 watts a output times 3, 224 or something like that watts of output. You might want a 300 watt or 350 watt power supply in here, a little extra to drive the controller. And then depending on whose model you get, this can connect to Ethernet and to your Ethernet network, and you can run a long wire from the weatherproof box across your front yard all the way in through your house and into your router, whatever it is. Now, I just used a little switch here. Most of them don't look like this. Most of them have antennas on them or whatever. But you can run it into here, and then your laptop that runs your software can be configured to the same network, whether it's wired or wireless. The outputs here each have an example of how you would daisy chain lights, and you can actually mix and match these lights if you want. You don't have to put all the same type on the same output. It just makes it easier from an addressing perspective when you tell it what's it's doing to that line. In dumb RGB, addressing isn't that difficult because you're basically just lighting this wire and saying, light up red. And so everything on it turns red. But like I said, you don't have to wire them the same reels on the same outputs. If you wanted this reel here to be a different color than this reel, you could have wired them on a different output here. Now, depending on whose model of dumb RGB controller you get, this can connect directly to your Ethernet, or it might not be able to. So you want to be aware of that. In my case, in my house, I have an output on my RGB controller, my dumb one, that doesn't connect to Ethernet. It has to connect to a regular DMX network. So what I have is a DMX port here, which looks exactly the same as a computer network, but it's not a computer network, and it has to plug into a DMX network. So I have a smart controller that it runs to, and I'll show you that one when we get to the hybrid. But this is a typical dumb RGB setup. If we go on to the smart or the pixel-based RGB setup, this lighting looks exactly the same. The only difference is we swapped out the controller and we put in different types of lights that are smart pixels, not the dumb ones. So these can individually be addressed and individually be lit. And they work basically the same. The only difference is when you put output here, it's actually 3 wires. When I say 3 wires, it's 3 little wires and 1 big wire. So it has 3 little cables that One of them carries 12 volts, one of them is the ground, and one of them is the data cable. We'll show you that in the wiring momentarily. And that's how it allows us to address every single pixel individually. So, but the setup's basically the same. The power supply runs into the controller. Controller feeds power to the lights and also feeds data to the lights. And on almost every smart pixel RGB controller, you have an Ethernet port. You can run a wire to your network, and your software then can control it. There's some addressing to give these things when they're connected to the network, and whether it's dumb or smart, you have to give them an address on the network. We'll be covering that in the next video in this series. So that would be the generic smart pixel setup. Now, as with the dumb, with a smart, you can have more than one of these. So I could plug in a whole nother controller that runs a whole bunch of other lights. So this power supply might be a 400 watt or 350 watt power supply. I might be able to drive, 8 reels of lights off this or 10 reels of lights, and that's about it. So if I want to drive something else, then I got to actually put another controller in. Another thing to keep in mind, you have these wires that come out to the lights. They're called pigtails, and whoever you buy, they have these nice waterproof connectors, but they're relatively short. They're probably a meter longer, 3.5 feet or something like that. And so you're not going to be running them real far from the controller unless you buy extensions. And you have to be aware that there's loss and restrictions on power when you run extensions. So if you run extensions, that's going to have impact on your power consumption. So keep that in mind. But you're going to basically want to put your controller somewhere where you can leverage all the outputs. So let's look at a hybrid now. This is a mix of both the RGB and the dumb one and the smart pixel. And this is actually very similar to what my house is set up. I have a computer here with it's on the wireless network. This is a wired illustration, but mine's wireless. And then my cables run out of the house, across the front lawn, into the controller. It actually does this 5 times. There's 4 times. There's 4 different smart controllers out there. Each of them have outputs running different types of lights. And the one I illustrated here is the one that runs my house lights, these C7 bulbs over here. So what I did on that one is I have that connected to Ethernet. Then one of my outputs is special. Actually, this illustration, this should actually be tied into this output, because on that controller, this is the actual special output for DMX. So what I mean by that is these outputs are voltage, and they are data for smart RGBs. These outputs here are dumb DMX outputs. So this in itself is a dumb output, and it goes to a connector on this board. And this one has its own power supply, which I should have actually duplicated that. And we should have 2 power supplies because this one's in its own box. Let me just take this one and just to make sure I properly reflect that, we'll just put one of these down here in the background, just so you know that that's actually the way it really looks. So this one's in its own box, this one's in its own box. There's a wire between them that carries the data from DMX to DMX in, and it feeds these things. Now in my input, in my network, these are all floodlights here. I don't have these types down here, but mine are all floods. There's 2 floods per output. So we have a smart pixel controller driving smart pixels. We have a dumb RGB controller driving dumb floodlights. Each of them have their own power supply. The controller is connected to the wired network, and then the computer is wireless to the network. And this sets up pretty well, okay? So there's 3 different setups, one to show you the dumb, one to show you the smart, and one to show you a hybrid, so that you get a good understanding of how it all goes together. So let's next step into the last 2 parts of this particular video, which is going to cover how the wiring works and how colors get on the wire. And the reason I cover this is because it gives a good understanding of dumb RGB versus smart RGB or smart pixel, and then how colors are represented. So this gets a little confusing at first, but I'll explain it. So let's go to this particular slide. I talked about there being 3-wire versus 4-wire, and there's actually 5, and I believe there's a 7 too, but there's other wiring technologies. I'm going to give you the two most common, a 3-wire and a 4-wire. The 4-wire is used by dumb, and that's at the top half of the screen, okay? And as I mentioned, each light, each LED is actually 3 LEDs, a red, a green, and a blue, and any intensity of those can represent any color. All of them full blast represent white. So if you mix a red flashlight on the wall, on a white wall, with a blue flashlight with a green flashlight, you'll actually mix the circles, you'll produce a white light. Any differentiation there on the intensities will represent different types of lights, and you'll see that on the next slide. So, well, let's jump there real quick, shall we? So color, as you can see here, and if I could zoom into this, let me see if I can do that, or I'll just make it bigger here. You can see that this color blue, the red would be at a 96 intensity. This is, I believe, out of 255, 1 to 255, or 0 to 255. With 255 being completely bright on and 0 being completely off. So red at a 96, green at a 122, and blue at a 201 will produce this pale, not pale, but this kind of dull blue light. So we represent colors that way, and that's how we produce any color with those 3 different colored RGBs, red, green, blue. So jumping back here to the wiring, the way dumb RGB works, and it kind of will let you see why you can only have all the lights on that turn a particular color, is because we have 4 wires. Each one gets voltage, and then you have the ground, which is the return. So think of it like plumbing. The electricity goes out and it comes back on the ground. So what happens is every LED is connected to the ground, and it's connected to its particular color wire, every single one of them. So if I put no voltage on blue, no voltage on green, and I put red at 255 or full voltage, full 12 volts, this one will light up, these 2 won't. This one will light up, these 2 won't. This one will light up, these 2 won't, etc. And I'll get a line of red lights. There's no way to individually address these. You're basically putting different voltages on these 3 wires, and based on that, you will light these LEDs on every single light on this strip, and they will all be the same color. So the controllers are pretty simple for this, and that's why you get one string all being the same color. If you daisy chain another string in, of course, you're extending the reds, the greens, and the blues and the ground just onto another strip of lights to make it longer. And the only thing you have to compensate for that is to make sure you have enough power coming out that output, but they will all turn the same colors no matter how many strings you put on there. So let's jump down now to smart pixels, which only use 3 wires. These work a little bit more like a computer network does. We have a hot wire, which puts voltage on the line. Basically, think of it like power. Hot, red, and black are hot and ground, positive and negative. And they provide electricity to the wire, to the strip, and to this little chip at each location of each pixel. Now remember, a pixel is like an LED. It's 3 little LEDs, one of each color. But we're powering the chip. And then the chip is going to receive data off the data line for its address. Let's just say this chip is address 1, 2, and 3. This address here is 4, 5, and 6. This is 7, 8, 9. Actually, they have 3 addresses, one for red, one for blue, green, and one for blue. So this would be 1, 2, and 3, 4, 5, and 6, 7, 8, and 9. So this pixel picks up its addresses for 1, 2, and 3, reads it, processes it, and then turns the voltage on the appropriate amount to each one of these lights. And if each one is capable of doing that, that's why we can address, because we're using data to tell each pixel, to each WS2811 chip, how much to light its particular lights. It manages those 3 lights. By sending data that way, we can control each and every individual pixel. We can change them different colors. You can turn them on, off, different patterns, different blinking. The data comes across and they pick up only their data. So that's how the 2 and 3 wiring work. That's how we get smart pixels over dumb RGB pixels, dumb RGB LEDs, sorry. And that's how 3 LEDs, a red, a green, and a blue, mix to produce just about any light. So let's jump again down to the last slide here, where we're producing color. Now, I've picked the same slide here for both, and as I mentioned, when you produce this medium blue, this dull gray blue. These are the values for red, green, and blue. So what happens on the 4-wire dumb RGB, it pumps the red at 96 out of 255 voltage. So if you figure full 12 volts is 255, it's a percentage of that, so it's 96 out of 255. It puts that much voltage on the red wire, and the red doesn't get that bright as reflected here. It gets this kind of pale color. The green is about half intensity, so the green will come up in about half, and then the blue at 201 is nearly full intensity. And mixing those colors, because those pixels have their LEDs so close together, and they're usually under some sort of plastic cap, the cap actually shows up this color blue. So that's how this color would get onto a strip of dumb RGBs, and they'd all turn that color blue. In the case of the smart pixels, these pixels have this WS chip, as I mentioned on the previous slide, that pick up their data. Okay? Now, what they do is they are each pixel is going to have 3 channels. Now, channels you can think of for right now until we get into the next video is an address, a location to send things. So down the wire, the controller is constantly sending streams of data. And every time this WS2811 chip sees 10, 11, and 12, because that's what it's supposed to pick up, it actually doesn't quite work that way. It has to do with removing data, and it picks up the first ones at the head of the line. But we'll explain that in the addressing video to come. But pretty much what happens is when the 2811 chip sees its data for its channels 10, 11, and 12, it picks them up. Then it changes the voltage going to each LED based on the number that's set into the channel. So channel 10 is its red, channel 11 is its green, and channel 12 is its blue. And then it will provide voltage to 10, 11, and 12 at 96, 122, and 201, thus producing this color blue. So that's how the actual chip picks up the data and passes it off, and that's how we get the color representation on the wire. Hopefully that makes some good sense to you. Obviously, you might have, for lights, we have 3 LEDs, so we mix only 3 colors. In true DMX usage, you don't have to use 3 channels for a device. And what I mean by that is you might have something that needs to be turned on or off, like you're in the theater and you want to turn, I think I've used the example in the past video of a fog machine. You want to turn it on or you want to turn it off, or maybe you want to have different in-betweens. You could actually drive it based on an amount of voltage or based on a DMX setting. So again, it all depends on what you buy, but you don't have to use 3 channels for that. We'll get into the addressing in the next slide, so I hope this gives you a good introduction as to smart and dumb pixels, how they're wired together in a home illustration like this, and basically how the color is represented, why 3-wire for smart and why 4-wire for dumb, and why dumb can only do one color down that string. In the next video, we'll cover addressing. We'll start with DMX and we'll go into Ethernet. I hope you enjoyed this. We'll see you in the next one.